Hello dear students, all of you, good afternoon, how are you all? Hope you are all doing well and doing well for advance also, right? So first of all, welcome to Infinity Learn, where learning is infinite and fun. Dear students, those who are all preparing well for advance, my suggestion is, earlier also I have discussed in the strategy classes, that choose certain important, I do not say important, some exclusively favorite topics and master them, right. You see, when I thought of doing certain videos related to advance, many of my students have asked to do something on permutations and combinations, especially certain areas like one, distribution of balls may be identical or dissimilar into boxes, as well as number of integral solutions related are the things asked by the students. So, in this class I am going to explain such a important subtopic, of course useful for mains and main objective is for advanced. Here I am going to bring you many models at one place in the form of tables, so that it may help you to understand the things better, right dear students. So, by the way, for the new students, yeah, this is BS Math faculty for IIT JEE, right dear students. Shall we move on to the topic? Chale, right, good. Fine dear friends, you see class flow, what are the things that we are going to see in this class? You see, division of dissimilar things, in the sense, you see, yeah, division of dissimilar things into, one second, let me take the marker, pen, right. Division of dissimilar things into groups, at the same time distribution of dissimilar things into boxes. So, division is different, distribution is different. In the same way, here I have taken dissimilar things. Now, the second case is identical things, similar things. In this case, how to do the division into groups, distribution into dissimilar boxes, and after that I want to extend a little more of this particular concept based on the time, right dear students. Chalo, first one, division into groups I want to talk, especially dear friends. You see, when you take certain things, say dissimilar things, suppose you are having 4 dissimilar objects, say 4 different kinds of chocolates. So, these chocolates are to be distributed. First let us divided into 2 groups. In how many ways we can divide? Suppose the 4 objects are, say, A, B, C, D. I want to divide into groups such that one group contains 1, other group contains 3. So, can you say the groups? Yeah, A, B, C, D is one group, B, C, A, D is one group, C, A, B, D is other group, and D, A, B, C is the other group. Exclusively friends, we can divide into 4 ways. In fact, you might have understood the phenomena here. 4C1 ways will come, because whenever you choose one object out of 4, automatically it will be divided into 2 groups, right, A, B, C, D. So, the number of ways of dividing 4 objects into 2 groups having 1 and 3 is 4C1, which is nothing but 4 factorial by 1 factorial into 3 factorial. You know it well. Now, my question is, suppose 4 objects are to be divided into 2 groups of 2 items each, that means 4 into 2, 2, how many will come? Can I just say 4C2, which is in fact 4 factorial by 2 factorial into 2 factorial, am I correct? Let us see friends. Out of 4, say A, B, C, D, if you write AB one group, CD, AC, BD, AD, BC, then BC, AD, BD, you can say AB, and CD, which is BD means you can say AC, CD means AB. Here you got 4C2 because these are the number of ways of selecting 2 objects out of 4. You got 4C2 6. But friends, this division ABCD is same as CDAB, these two same division. Whereas ACBD you see and BDAC are the same division, in the same way these two also. Because of equal number of division, certain divisions have become the same. In fact, into half I have to write, into 1 by 2 factorial I have to write. Whereas when you divide into 2 different things, you no need to write because all the 4 are distinct, right friends. So my dear students, in this particular case, you see, if at all you want to divide 5 items into 2 groups having 5 as 2, 3, in how many ways you can divide? The answer is simple, 5 factorial by 2 factorial into 3 factorial, which is nothing but 5C2 or 5C3. Whereas 10 objects I want to divide into 2 equal 5. How many ways can you divide? In fact, you can write 10 factorial by 5 factorial into 5 factorial into, yes, 1 by 2 because 2 equal groups, right friends. For example, you want to divide 10 objects into 3 groups, 2, 3, 5. In how many ways you can divide friends? It is simple. If you want to divide into 3 groups, first you divide into 2 groups. 10 you divide as 2 and 8, this can be done in 10C2 ways. So you got 2 items here, 8 are left. Now the remaining 8, you see, you need to divide into 3 and 5. In how many ways you can divide? You see, it is very simple. 8 items are to be divided into 3 and 5 means you select 3, automatically it will be separated into 3 and 5. So we have to do both the works by fundamental counting principle of multiplication. We have multiply both these things. If you just multiply these, you see the phenomena. This is 10 factorial by 8 factorial into 2 factorial. This is 8 factorial by 3 factorial into 5 factorial, right. You just cancel 8 factorial. You see, the answer is quite a bit interesting. 10 factorial by, you see, 2 factorial into 3 factorial into 5 factorial, right. So friends, in this way the dissimilar items can be divided into groups, fine. So dear friends, let me extend the logic to this. You see, division and distribution of dissimilar things. Let me take this table. Friend, this is a table consisting of, I have taken 16 dissimilar objects. I want to divide this into 2 and 14. Division in this column, distribution, then next arrangements. 3 kinds of problems, 6 cases. 6 3s are 18 problems are there in this particular table, right. So just find the difference so that you can understand well. You see, in the first case what I want to say is, there are 16 dissimilar objects. I just want to do division. First let me focus on division. All the 16 items are dissimilar, different items. Now I want to divide this into 214 means my intention is divide this into 2 groups of 2 and 14. By the point what we have discussed now, it is 16 factorial by 2 factorial into 14 factorial. Am I correct? Yes. Now I think you can answer this. Those 16 objects are to be divided into 2 groups of 8 each. Can you say the answer? Yes. 16 factorial by 8 factorial into 8 factorial. Because of 2 same, you will get into 1 by 2 factorial. Clear friends? Then next, now I want to divide 16 into 3 groups having 3, 6, 7, right. Now you divide 16 factorial by 3 factorial into 6 factorial into 7 factorial. It is very easy to divide. The logic is, you see, 16C3 into 13C6, that is all. Of course, we can write like this. Here all are different, so no need to write into something. Now you see, I want to divide 16 into 4, 4, 4, 4 equal groups. How to divide? Yes, 16 factorial by 4 factorial into 4 factorial into 4 factorial into 4 factorial 4 times, and you see when 2 same you got 1 by 2 factorial, if 3 same 3 factorial will come, 4 same 1 by 4 factorial comes. Like you see, if there are two things, you see for a division suppose like A, B, C, D, E, F, G, H, you see 4 factorial times same kind of divisions will appear. This is why 1 by 4 factorial, right friends. Then the next one, you want to divide this into 3 groups having 5, 5, 6. You see this is a different question, 2 same 1 different. Same 16 factorial by 5 factorial into 5 factorial into 6 factorial into, in how many say 2 same 1 different, you try to write 1 by 2 factorial into 1 factorial. You see friends, 4 same 4 factorial, 2 same 2 factorial, 2 same 1 different, you have to write like this. You can just observe the things, you will understand why it is so. Now the last one, just for understanding the concept, the 16 is to be divided into, I think you can see 2 1s, 4 2s, 3 3s. Can you say the answer? Yes, 16 factorial by, yes, this is 1 factorial 2 times, 2 factorial 4 times, 3 factorial 2 times. Up to here you can write easily. Then the next point is important, that is this is 1 by 2 factorial into 4 factorial into 2 factorial. Like you see, like target, Mississippi, mathematics kind of problems, you write total factorial by 2a's 2 factorial, 4b's 4 factorial. In the same way, you don't write the numerator, but denominators you write 1 2 times 2 factorial, 2 4 times 4 factorial, 3 2 times 2 factorial. In this way friends, certain dissimilar objects and dissimilar objects can be divided into groups. Fine friends. Now distribution, the question is, now forget about this, 16 dissimilar objects are to be distributed into dissimilar boxes. Boxes are dissimilar, that means here 2 groups, so I am taking 2 boxes, one is small box, one is big box, abhi red colored, black colored, some way they are different. You see friends, if at all you want to distribute, you write the corresponding division, I named it as D, you write the division. Now after each division you are having 2 items in one hand, 4 items in other hand, 2 and 14. Now these two are different, you distribute into these 2 boxes, as the boxes are distinct you will get into 2 factorial. That is all. Clear? This is division, this is distribution, right. You see, in the same way arrangement can also be continued here. After distribution, that means suppose 2 balls here and 14 balls here. Now you just divide, then distribute, then arrange these. These 2 balls can be arranged in the box in a line in 2 factorial and here 14 factorial. This is arrangement friends. Division is different, distribution is different, arrangement. If at all you want to distribute, first divide then distribute. Here in boxes if you want to arrange, divide, distribute, then arrange in the box, within the box, right. Fine friends. Now can you answer this question? You want to distribute into 2 different boxes. You have divided, D means answer is this here, fine. Then distribute, you see friends, you have 8 objects here, 8 objects here, 2 different are there, in how many ways you can distribute. One important point friends, even though you have 8 8, the items are different, here may be 1 to 8, 9 to 16, even though they are equal in size, the objects are different, boxes are different, but still you will get 2 factorial only. Because of 8 you do not get 1 factorial, it is 2 factorial only. Okay. Then at the same time friends, here suppose you want to arrange, this is same, I write DD means divided, distributed, then arrangement. These 8 can be written in 8 factorial ways, 8 factorial ways within the boxes. I think the rest of the things it is not a big deal to discuss, right? You see, first you divide 3 different groups, 3 different boxes, so you can write in 3 factorial ways. After division, distribution, you just write the arrangement, which is 3 factorial into 6 factorial into 7 factorial, right? So in the same way you can complete the rest of the things. Clear, friends? I think you got the clarity of division, distribution, arrangement of n dissimilar objects into n dissimilar boxes. Clear? Right? Fine, dear students. Now, yeah. The next one, dear friends, division and distribution of identical things. The objects are quite a bit identical, same items. Now, how to divide and distribute? You see, friends, let me take this table. Here also of the same kind, but just conceptual point. Arey yaar, you are having 16 identical objects, all are identical. In how many ways you can divide them into 2 groups of 2 and 14? Can anyone say the answer? Can I expect, friends? Can anyone? Right? The answer is only one way. All are identical here. All, suppose you just write A 16 times. You take 2 separate and 14 separate. That's all. Which 2A? All are same. So no difference. Division is one way. In the same way, in how many ways you can divide 16 identical into 8? Only one way. 3, 6, 7, only one way. 3A's, 6A's, 7A, 1A, one way. Any division is only one way, friends, for identical items. Clear? The next, now distribution into R boxes. Here how many boxes are there? 2 groups. So I have taken dissimilar boxes, small box, big box I have taken. Arey yaar, I have 2 A's in one hand, 14 A's in other hand. So size wise they are different. In how many ways I can arrange them into boxes? Number of ways of division is one way. Then distribution, 2 different items, because 2 A's, 14 A's into 2 different things into 2 factorial. Clear? Hope you got my point, right, friends? Now suppose you have divided this case 8. Okay, here already division is one way. Now you need to distribute into 2 groups. You see, friends, here 8 are, in the previous case dissimilar items, there are 2 different 8 items, whereas here 8A's one group, 8A's other group. That means they are same kind of 2 items are to be distributed into 2 different boxes. So first 8 in this, second 8 in this, or second 8 in this, first 8 in this, no difference. In fact, only one way, or else you can write 2 factorial by 2 factorial. In fact, only one way, right? Next, here division is one way. 3, 6, 7 items are there. 3, even though they are identical, 3A's one group, 6A's one group, 7A's one group, means 3 different items into 3 boxes. 3 factorial is the number of ways of divisions, right? Now 4A's, so division is one way and distribution into 4 different boxes, but items are same, only one way, or 4 factorial by 4 factorial I need to write. Fine. Next 5, 6. You see, division is one way, then distribution 5A's, 6A means 3 items of which 2 same, like P, Q. You need to arrange into 3 different boxes, means 3 different places. 3 factorial by 2 factorial. Am I correct? 3 factorial by 2 factorial. In the same way, here also division is one way and distribution. So these things means you can treat like P, Q, R, S. How many ways you can distribute? 4, 6, 7, 8. 8 factorial by, you see, 2 factorial into 4 factorial into 2 factorial, because 2 1's are there, 4 2's are there, 2 3's are there. Clear, friends? In this way, we can divide these identical items into boxes. Next friends, arrangement. Now you can say the answer. So 16 identical objects are taken. I have divided into two groups these many ways, distributed. After this distribution, division distribution, and you see two A's must be arranged within the box, all are identical. Arrangement is only one way, we cannot further arrange because all are same identical. Arrangement is not going to give any extra case, right? And hence my dear friends, I mean to say here, yeah, so arrangement is quite a bit same into one. Here I can say division distribution into one only in this case. Fine friends, by this time you might have seen how to divide, distribute, arrange n identical objects into our boxes. Friends, in the previous case we have seen dissimilar objects into cases, identical things into cases. Clear dear students? Clear? Any doubt? Fine friends. Then the next one, you see important points I want to highlight here which are required for the further discussion. You see, number of ways of selecting R things out of n dissimilar things. Suppose you are having n persons from which you want to select R persons, it can be done in NCR ways. Suppose all the things are identical, in how many ways you can select R object? Only one way only, because all are identical things, right? Okay, Aman Verma and Srini, yes, hello, hi, how are you? Yeah, fine dear students. You see, here you see when all are identical, number of ways of selecting R things is only one way. In the same way, you see total number of selections, for example out of n objects, total number of selection means selecting one object, two objects, three objects, n objects, none of them. Total number of selections, you know well, it is 2 power n, because NC0 plus NC1 plus NC2 plus NCn is going to give 2 power n. And number of identical things, suppose friend there are 10 identical objects are there, in how many ways you can select? Means you can select one object, two objects, because all are identical, 3 objects, 4 objects, 10 objects, none of them. So n plus 1 ways. Please find the difference between these two. Number of ways of selecting R objects from dissimilar things NCR, identical things one way. Total number of selections for dissimilar things 2 power n, identical things n plus 1, right. The next friends, division into groups, just now I have seen, I had already told, if there are n dissimilar objects friends, 10 items, division into 2 3, 2 3 5, 5 5, 5 5 5, like 12n I have divided into 2n, 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 3n, 3n. All these cases just now we have seen how to divide when the objects are dissimilar. This is the case of dissimilar objects. Just as a review I have written here, when the items are identical, yeah, in how many ways you can divide? You see 10 objects are to be divided into 2 and 3, only one way, one way, one way, one way, one way, right. Please find the difference between identical objects as well as dissimilar objects, right dear students. Here another important point, the number of ways of distributing n identical balls into R boxes. I think all of you can recall by this time the formula is n plus R minus 1 C R minus 1, right. Do anyone want the logic? Suppose there are n identical balls, for example 10 identical balls are to be distributed into 3 different boxes. In how many ways you can distribute friends? Since there are 10 identical balls, you write 10 identical balls on the ground, this is 5 and 5, 10. If at all you want to divide into 3 boxes, you just try to take 2 lines, say suppose you have drawn one line here, one line here, two lines are enough. The number of balls before first line you write here, between first line and second line you write here, the right side of this you can write here. So 3, 2, 5 is one way of distribution. They are identical, which 3 is not going to be a matter, right. Suppose instead of this, instead of this you have written here and here. So first box is going to contain 7, second is going to contain 0, third is going to contain 3. So friends, the number of ways of arranging 10 balls, 3 boxes means 2 lines you take, that is 3 minus 1 identical lines. In how many ways you can arrange, friends? These many factorial by 10 factorial into 2 factorial, which is friends 12C2, which is 12 is nothing but 10 balls plus 3 boxes minus 1 C3 minus 1. So friends, you know this number of ways of arranging n, distributing n identical objects into R boxes is without any restriction n plus R minus 1 C R minus 1. Am I correct? N plus R minus 1 C R minus 1. Now the next one is suppose distributing n identical objects into R boxes such that no box is empty. Friends, in how many ways you can distribute 10 objects into 3 dissimilar boxes such that no box is empty? You know what I do? First I put one ball in all the 3. 1, 1, 1 I have kept. So I am left with 7 balls, 3 boxes. Now you can distribute these 7 balls, 7 identical balls into 3 boxes in any way, right? So friends, this is going to be n plus R minus 1 C R minus 1, which is 9C2. In fact friends, NC, this is n, this is R, is going to become n minus 1 C R minus 1, right friends. So the number of ways of distributing n identical objects into R balls such that no box is empty is n minus 1 C R minus 1. I think you can recall these 2 points now. Now with the help of this, you see this particular box. This box comprises 4 3s are 12 problems. You see this question, friends? N dissimilar objects into R distinct boxes. Objects distinct, boxes dissimilar. Here n dissimilar into R identical boxes, objects dissimilar, boxes identical. Here n identical balls into R dissimilar. Here balls identical, boxes dissimilar. The fourth case, both are identical. I think you got my point. You see boxes, you see objects, you see dissimilar, 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 identical, identical, dissimilar, identical, identical. These 4 cases I have given. In each case 3 problems I have written, friends. You see, yeah. So in this case, first one you try to write, friends. This one, you know, n dissimilar objects I want to divide into 2, 3, 5 and distribute. You see, for example, I have given 10 dissimilar objects are to be distributed into 3 boxes, where the boxes receive 2, 3, 5. Just now we have seen. You see, first you divide, then distribute. Divide, friends. 10 factorial by 2 factorial into 3 factorial into 5 factorial divided. Now you are having 3 things. You have to distribute into 3 dissimilar, 3 factorial. Fine. The next, friends, n dissimilar objects into 3 identical balls. So where the boxes receive, you see 10 dissimilar objects are there, whereas boxes are quite a bit identical. Now friends, in how many ways you can distribute? First you divide here. So 10 factorial by 2 factorial into 3 factorial into 5 factorial gives the number of divisions, right? Then distribute. You are having 2, 3, 5. The boxes are identical. So 2 going in any box is the same. So in this case, when the boxes are identical, distribution is one way. right. The next friends, n identical balls are to be first divided into 2, 3, 5. Division is one way because balls are identical 2, 3, 5. Now these are of different sizes groups, you can distribute into different boxes in 3 factorial ways. Whereas now balls identical, divide them as 2, 3, 5 one way, boxes are also identical, distribution is also one way. Please find the difference between distribution of the items into 2, 3, 5 groups where DD, DI, ID, II. Please find the difference, you can easily understand, right dear friends. Now this you can say the next question, a box can receive any number of balls. That means you see there are 10 items, 3 boxes we have to go. First ball can go to any number of any box, right. First ball can go to any of the 3 boxes. So 3 ways, 3 ways, 3 ways, 10 times 3 power 10, like number of functions concept. Number of functions concept. You can just write this is nothing but number of functions. Okay. Whereas n dissimilar into are identical boxes. In this case you need to divide first in each case, like 0, 0, 10, 0, 1, 9, 0, 2, 8, like that you divide into case, and in each division number of case is 10 factorial by 0 factorial into 0 factorial into 10 factorial into distribution is 1. That is the thing. Like that you have to write all the cases. It is a rare case. The next, n identical things into r boxes, there is no restriction, it is n plus r minus 1 c r minus 1. Whereas balls are identical, so division means here, division of course same, 0, 0, 10, division one way, distribution one way, each one is one way, 0, 1, 9, division one way, distribution one way, right, that is all. Now the last one, no box is empty case. Here you see friends, 10 objects are to be mapped into 3 boxes such that no box is empty, means like number of onto functions logic, onto functions logic it is, right friends. You see 10 are to be mapped into 3 items such that no box is empty. Whereas the next one, here also n dissimilar into or identical case, the same things you write, but no box is empty means avoid 0 cases, that is all, avoid 0 cases, remaining same, avoid 0 cases, right. The next, here n identical items, no box is empty means n minus 1 c r minus 1, that is the thing. And here you take same kind of cases, avoid 0 cases, avoid 0 cases, 0 cases, right friends. So friends, with this you might have got some clarity how to divide, of course distribute, not only that, in all the 4 special cases DD, DI, ID, II, how to distribute into specific case. This is 2 special cases, like you see a box can receive any number of items or no box is empty. You know, it is beautiful applications, number of integral solutions will be there, various kinds of modal problems related to number of integral solutions will be done in the next class, right friends. Hope you have enjoyed the thing, and thank you dear students. Okay, see you and all the best for your advanced preparation. Maintain the tempo, do the best. Infinity Learn is always ready to help you in some extent, right. Thank you, bye bye.